In this video, I'll go through Chapter 17 Applications of Integration. How do we use definite integrals to find the area between a curve and a line? So let's do a quick recap of the concept needed in this part of the chapter. To find area between curve and a line, simply you need to make sure you know what's the lower limit and the upper limit. Then you can take the curve, equation of the curve, the expression of the function of the curve, minus a wave function of the line, and you integrate that, or it can be a function of the line minus a wave function of the curve. This depends on which is above, meaning in your graph, in your sketch, which line lies above the other. So let's look at one simple illustration. Let's say I have this diagram over here. I want to find area A. Okay, I know that I have this line here, y equals to x plus 2, which is above the line y equals to 1. So therefore, to find area A, I know that the upper limit is 6, the lower limit is 2. So very simply, by definite integral, this is simply integrating from 2 to 6. The line that is above is x plus 2. Y equals x plus 2, so this is x plus 2 minus away the below part, which is y equals to 1. Minus 1 dx. Okay, then very simply, I just need to simplify and evaluate this definite integral. X plus 1 dx, I will get integrating of x squared over 2 plus x 2 to 6, and therefore I'll get the answer over here, which is 6 squared divided by 2 plus 6 minus away 2 squared divided by 2 plus 2. Okay, so if I have to evaluate this part out, I should be able to simplify here and get 18 plus 6 minus 2 plus 2. Okay, I should get 24 minus 4, answer should be 20 units square. Okay, so this is one simple example. Now let's look at a little bit more complicated question. Okay, find the area enclosed by the curve and the line. So the concept is still the same. To find this area here, the area is simply, I note that the curve lies above the line. Okay, based on this question here, the curve is given by this equation, y equals to 2x minus x squared. The line is given by this equation here, y equals to negative x. I know that the lower limit lies at origin 0, upper limit between the intersection between curve and line, this value here, the x value is 3. So therefore, this means that this is simply integrating from 0 to 3, curve, which is 2x minus x squared, minus away the line, which is negative x, since the curve lies above line. And this is simply dx. I will simply be able to simplify this to become integrating from 0 to 3, 3x minus x squared dx. Then you integrate this from here, very simply you should get 3 over 2x squared minus x cubed over 3. Integrate from 0 to 3. And therefore you sub in your definite integrals, you should get 3 over 2 times 3 squared minus 3 cubed over 3 minus 0. Okay, final answer should be simply 9 over 2 units square. Okay, this is for the area here. But I think you may be confused about how come if this part of the graph lies below the x-axis, how come I can still take curve minus line? Okay, this expression over here works for all kinds of scenario. Why does it work that way? I'll do a quick explanation. I have drawn this diagram and split this into different parts. Let's say I know that the limits here are 2 and 3. Okay, so let's do it part by part. Why is the area of A1 and A2? Simply integrate from 0 to 2 and I take curve minus line and I'll get this entire area over here. Why is it like that? So let's do it part by part. Okay, if I were to write this down, integrating from 2 to 0, 2x squared, the curve which lies above the line, minus away the equation of the line. Okay, this, I can split this into integrating from 2 to 0, 2x minus x squared, the curve, dx, minus away, integrating from 0 to 2, and the line. Okay, and therefore, if I were to analyze this question without any context, this part of the curve, if I integrate just the curve by itself, from 0 to 2, this expression will give me A1. Okay, so over here, this is simply A1. then minus away. Now I'm integrating from 0 to 2, which I'm integrating this line. If I integrate this line, I know that this is below the x-axis. If I integrate from 0 to 2, I'll get a negative a2. This will be negative a2 value. And therefore, this will simplify to give me a1 plus a2. That is why, to find this total area here, you can simply integrate from 0 to 2 and take curve minus line. Okay. The next question is, how come to find this area over here, I just need to take the curve minus line and I integrate from 2 is to 3. So let's break this apart. Okay, if I were to use this definite integral over here, integrating from 2 to 3, I take curve 2x minus x squared minus away line, because the curve still lies above the line here. Okay, this is simply, over here, I simplify, I can break this down into integrate from 2 to 3, curve dx minus away, integrating the line 2 to 3, negative x dx. Then I analyze this question over here. If I were to just integrate this curve 2 to 3, I will get negative of a3. If I'm looking at this based on the curve by itself, if I integrate this curve here 2 to 3, I'll get this area here. Okay. Then over here, next I integrate this line here from 2 to 3. I'll get the negative of this entire area over here. So in this case here, minus away, I will get the negative of the entire a3 plus a4. Okay, then I simply break this down further. This will be negative area 3 plus area 3 plus area 4. Okay, and therefore I simply simplify from here. This is equal to area 4. That is why, even though here this lies underneath the x-axis, since the curve lies above this line over here, to find area a4, all I need to do is take curve minus line, this curve, equation of this curve minus equation of this line, then the lower limit to upper limit to find area of a4. Okay, so this is the explanation to how come this will work as long as the curve lies above line or line lies above curve, etc. Okay, so remember this important concept over here. Equation of area between curve and line, it can be either curve minus line or line minus curve. It depends on the diagram. You must know very clearly what lies above what in order to find the area between a curve and a line. Okay, and that's the end of this video.